So our independent samples t-test, this is relatively similar to what I was talking about previously in terms of the one sample t-test. The independent samples t-test can again be thought about as a signal to noise ratio. The signal being the difference in the mean scores between the two groups, and the noise being the variation around that average difference score. This is our t-test formula. This is our formula that we would use to calculate the t-statistic if we were doing this by hand. And you can see the numerator here is just the difference between the two mean scores, x bar 1 being the mean score for group 1, x bar 2 being the mean score for group 2. The denominator of this formula, the thing underneath the fraction sign, is representing the pooled standard deviation, which is also called the standard error of the difference between the means. And it's essentially just representing the amount of variability in each of our two groups, which is also the amount of variability between the different scores between the two groups. And on the right-hand side here is notation of what each of the individual elements in the formula represent. So in our particular data, we can use this t-test formula to calculate a t-statistic. So starting up the top for the second formula here, we know that our two mean scores, the mean intellect rating score for the audio condition and the transcript condition, are 3.65 and 5.63. It doesn't matter which is group 1 and which is group 2, as long as you're consistent throughout the formula. So here the transcript condition is group 1 and the audio condition is group 2. Which is which doesn't make any difference, as long as x bar 1 is the same group as standard deviation for group 1. And x bar 2 is the same as S for group 2. So as long as you're consistent between the two, it doesn't matter which is which. So we can plug our mean scores into there. We can plug our standard deviations into the denominator of the formula, and then we end up with a t statistic, actual value of our t statistic, of 3.5. As I said before, for the one sample t-test, if the t-statistic equals 1, if it's a value of 1, it means that we have equal amounts of signal to noise. And anything bigger than 1 represents more difference between the means in proportion to the amount of variability around that difference between the means. And remember that the point of getting an associated p-value that corresponds to a t-statistic is to be able to quantify the likelihood or the probability that we've obtained this particular t-statistic, in this instance is t-statistic of 3.5, if the null hypothesis of no difference between the two groups is true. The bigger the t-statistic, the less likely that is, the smaller that probability or the smaller that likelihood, and therefore the more likely it is that we're representing a true difference between the two means. We also need some degrees of freedom to go along with this, just like we did for the one sample t-test. And in the independent samples t-test, our degrees of freedom is calculated by our total sample size minus the number of groups minus 1, minus 1 again. So in this instance, our total sample size is 39, minus the number of groups we've got, which is 2 minus 1, minus 1 again. So 39 minus 1 gives us 38, minus 1 gives us 37. So 37 degrees of freedom in this particular independent samples t-test. So here we've got a t-statistic of 3.5. We can use that critical t table that I was talking about earlier to look at the critical t value for this particular sample size, this particular degrees of freedom. So again, we've got a two-tailed test of significance, which is what we're always going to be talking about in this course. Our critical alpha is a value of 0.05, which is representing a 5% probability of obtaining this t statistic if the null hypothesis is true. We've got 37 degrees of freedom. So our critical t value gives us a value of 1.687. So if we compare our obtained t, 3.5, with the critical t, 1.687, we can say that ours is bigger than that. Our obtained t is bigger than the critical t, and therefore we can reject the null hypothesis. So that means that the likelihood that we've obtained this particular t statistic, this particular difference between the means and this particular variability around the difference, if the null hypothesis is true, is very, very unlikely. And therefore, what we think has happened is that we're picking up on a real difference between the two groups. So that means that our two means are significantly different. If we were going through that same process, but rather than doing it by hand, we use Stata to calculate the t-test for us, then we'd go to the same place in terms of the menu system that we went to before for the one sample t-test, but we select the two sample t-test using groups. Our variable name on the left-hand side here is our outcome variable, our dependent variable, which is our numeric variable. And the group variable name is the variable that represents the independent groups, the two different groups that people are allocated to. So if we were going to do the same thing, doing the same t-test, but through the syntax way, i.e. writing out the written command rather than using the menu system, then this is how we do it. So in your command little window, you type the t-test command, then you list your dependent variable, your outcome variable, comma, by, and then in parentheses, your categorical independent variable, the grouping variable. And this is the kind of thing that we would get as our output. So it looks reasonably similar to the one sample t-test. It's kind of laid out similarly to the one sample t-test. But obviously we know that what this is doing is comparing the mean scores in terms of the average intellect rating between the transcript condition and the audio condition, and then seeing how different those scores are and how much variability there is around that difference to see if the difference is distinct enough to likely reflect a real difference in the groups in the population. So we've got our descriptive statistics in this first table here. You can see that we've got our descriptives broken down by the two different groups, and then the overall combined the total descriptive stats. And then Stata gives us some information on the actual difference scores. So this negative 1.98 is the actual difference between the two groups, and then the standard error of those two of the differences. We then get our t statistic itself, negative 3.52, and you can see that that's the same as the t statistic that we calculated a couple of slides ago. The only difference is here that it's a negative number, whereas ours was a positive number. And the reason for that is just because which group was indicated as group 1 and which one was group 2 is the other way around between how Stata did it and how we did it. It makes no difference. It just means that it's a negative t statistic, whereas ours was a positive t statistic, but it makes absolutely no difference whatsoever which one is group 1 and which one is group 2. Okay, so that's our t statistic value itself, this 3.52. As we calculated ourselves before, you can see we've got 37 degrees of freedom. And then just like before, we get 3 different p-values here. And the one that we always want to look at is the middle one. The middle one, which corresponds with a non-directional alternate hypothesis. And it's the two-tailed test of significance. This is always going to be the one that we're looking at. So you can see here that our p-value that corresponds with this t-statistic is quite small, 0.0011, which is definitely smaller than 0.05, which means that we've got a significant result here. So the likelihood that we've obtained this particular difference between the scores and this amount of variability around the difference, if there's actually no difference in the population, is very, very small. It's very unlikely. And therefore we conclude that there probably is a real difference between the audio condition and the transcript condition in the population from which this sample was drawn. There probably is a real positive effect of being in the audio condition, of communicating information in an audio way, in a sort of verbal way, compared to just reading written information. Because remember, that's what we're testing in this particular research question. So we've got a significant difference between the two groups, and the direction of that difference is that we have a higher score in the audio condition compared to the transcript condition. So if we wanted to write this up in a nice little kind of summarized manner to conclude it, we'd say that there's a significant difference between the intellect ratings of the two different groups, the audio condition versus the transcript condition. But we also want to say what the direction of the difference is, i.e. which group had the higher intellect rating, which group had the lower intellect rating. Because saying that there's a difference without saying what the actual direction of the difference is particularly useless. It doesn't actually communicate any information. So we always need to state the direction of the difference. Which group is higher, which group is lower. Remember, if we want to communicate the actual statistical information, we need to make sure that in our written summary, we have the mean scores and the standard deviation of both of our two groups. We need to have the details of the t-test results itself, so in terms of the t-statistic, the degrees of freedom, and the p-value, and a statement about whether it's a significant or a non-significant difference. And we also need information about the direction of the difference. So we could do it something like that here. We could say that the mean intellect rating in the audio condition, and then listing what the mean and the standard deviation is, was significantly higher than the mean rating in the transcript condition, and then listing the mean and the standard deviation of those, and then listing our t-statistic information and our p-value. And our p-value is written to 3 decimal places here, and that's just APA requirements. And then we have a comment about the interpretation of that. So I've written here, which indicates that raters gave higher scores to candidates when hearing their spoken interview compared to when reading the written interview. And that gives us some interpretation of the meaning of these statistical results. Because remember that the whole purpose of conducting the statistical tests is to be able to address our particular research hypothesis. So has this supported our hypothesis? Yes, it has, and therefore what that means is that there were higher intellect scores for candidates who had a spoken interview compared to those who had written interviews. This slide is just an overview of the different stata commands that we've used today, the written out syntax. And so in conclusion, what we've achieved today is talking about 2 different kinds of t-tests. We talked about the one sample t-test and the independent samples t-test. Hopefully it's been made clear to you what the similarities between those 2 tests are, in that t-tests are always looking at describing mean scores, average scores on some kind of numeric variable. In the case of a one sample t-test, it's comparing the average score to some other known population average, some external reference average. In terms of the independent samples t-test, it's comparing the average score between 2 independent or separate groups. And the important thing for you guys to know, to take away from this, is when each test is appropriate. And this is common throughout the rest of the semester when we talk about all the different kinds of tests. And the answer to that question is based on the research question and hypotheses that we've particularly got, the design of the study itself, the types of variables that are involved in this particular research question or hypothesis, but also the assumptions that go along with each of these tests. You also need to know how to actually do the test, in particular how to do it using a statistical program like Stata, so how to conduct a one sample t-test, how to conduct an independent samples t-test. You also need to know how to write up the test results. So because psychology uses APA formatting most of the time, there are certain APA requirements for how to communicate significance test results. But also there's just things to think about in terms of making sure that you interpret the test rather than just presenting the numbers of the statistical test itself. Something else that we're going to talk about next week, which we just couldn't fit into today's lecture, but is still going to be very much relevant to today, is how to calculate effect sizes. So I've talked to you in the past about effect sizes and about how they're really, really important to report and to understand in conjunction with significance tests, with p-values. So we're going to talk more about that next week, about how to calculate effect sizes and how to interpret effect sizes. So well done on surviving your first foray into statistical hypothesis testing, the 2 different kinds of t-tests we talked about today. And hopefully you'll kind of get your head around it and be able to understand things more and more as we go throughout the semester, as we reiterate and kind of go over a lot of the concepts that we talked about today, just applying it to different kinds of tests.